The concept of distance is a very important idea in mathematics. It turns up in geometry, it turns up in all sorts of things. So let's think about what the distance between two numbers actually means. So distance. So the distance between two numbers. Two numbers, A and B. What should that equal? Well, intuitively, it's going to be the length of the line segment connecting the 2 points. Which connect them both. Connecting A and B. So just as a very simple example, I mean, if I had a number line here like this, and if this point is A and this point is B, then the meaning of the distance between the two would be the length, let me write it slightly larger, it would be the length of this line here. Okay, so the concept of distance is that length. Now this makes sense beyond points on a line. You could talk about points in a plane, you can talk about points in a three-dimensional space, whatever. But it's always the same, right? You draw a straight line between the two, it's the length of that, that's what the distance is. Now, something to say is length is always positive, right, by convention. So this is always positive. Or maybe I should be more strict, it's always greater than or equal to 0. The distance between this, like A from B, if A is equal to B, of course, is going to be equal to 0. So maybe I should write always greater than or equal to 0. So what I want to do really is come up with a really simple way to calculate this distance. Aim. Find a simple way to calculate this distance. That's what I want to do. So let's introduce some notation, shall we? There's this position on the number line which is privileged among all, namely the 0. The 0 kind of sits right in the kind of the crossroads between positive and negative numbers, so it has some sort of special privilege. So it's natural to have kind of a baseline for all of this as the distance from a point on a number line to 0. So that's what the absolute value is. The absolute value of a number x is by definition equal to the distance from 0 to x. The distance from 0 to x. And of course we write this in familiar notation written, it's kind of two vertical lines like this. We've already seen this. Right, so let's make sure this is highlighted. This is important, right? This is a definition. At least a pretty good intuitive definition. So I'm going to say that here, right? So this is a definition. This is the meaning, the geometric meaning of an absolute value of x. That's the distance from x to 0. So let's do a few examples, shall we? So let's take a number line and let's mark my position 0. Let's mark two other positions. Let's mark 3 here and let's mark -5 over here. Okay. So what's going to be the absolute value of 3? Well, the absolute value of 3 is going to be the distance. It's going to be the length of this line segment. Right, that's going to be what the distance is between 0 and 3. So this length, of course, is equal to 3. Okay, so this implies the absolute value of 3, the distance from 0 to 3 is just equal to 3 itself. Brilliant. What about minus 5? Well, minus 5, the absolute value is going to be the length of this line segment, isn't it? Okay, it's going to be the length of this line segment, and that visibly is of length 5. So that would imply the absolute value of minus 5 is equal to 5. So let's kind of precisely capture this. This is something we've already seen, but it's nice to do it really carefully. So more precisely, so more generally, in fact maybe I should say more generally. More generally, the absolute value of x is equal to x. So this is piecewise notation. So it's equal to x if x is greater than or equal to 0, and it's minus x if x is less than 0. So up here, this is equal to minus of minus 5, just to make sure we understand on this. You understand this? So this is piecewise notation. This is a way of describing a quantity or something which has a different meaning depending on the circumstances. And the circumstances here are on the position of x on the number line. If it's positive, it's just x. If it's negative, it's minus x. Right, so this is the absolute value kind of precisely described. Let's make some observations about this. So there are two I'm really going to look at. The first is the absolute value of x is equal to the absolute value of minus x for any x, for any number. Okay, why is that true? Well, let's draw a little picture. So I'll draw a little picture. If this is 0, I'll draw a picture where x is positive. So if this is x, then minus x is over on the other side, and it's totally symmetric. So this length here and this length here are exactly the same. These are the same length. Woo. Same length. So that's kind of the geometric reason for it. You can do it agonizingly formally if you want, using the definition, this piecewise notation definition. I think it's better just to have the picture in your mind. So this is all well and good, but how do I actually describe what the distance is for two numbers? So again, I'm sure this is something you're very likely to have seen, but it may be in a slightly restrictive circumstance. So can we use this? So this is only notation really to describe the distance between 0 and a position x. If I have two positions, like an A and a B, neither of which is 0, can I use this in some way to find the distance between those two positions? So can we use this to describe so maybe this is an observation. I've only got one observation. So the question is, can we use this to describe the distance between any two numbers, not just 0 and your number. Numbers, let's say A and B. So I think we should do this by example. It's a good plan. So example. So let's take, for a second, let's do something really straightforward. Let's put 0 here, Let's do 0 here. So I'm going to have 2 copies of this, so let me copy it down below. You'll see what I'm doing in a second. And let's think about the numbers 3 and 7, shall we? So we'll do 3 here and 7 up here. So I want to know the distance between 3 and 7. So the distance between 3 and 7, of course, is going to be the length of this line segment. Now it's pretty obviously equal to 4, but I want to do this super duper carefully. I want to relate this back to absolute values. So how am I going to do this? Well, let's just notice for a second. Let's notice for a second that this isn't terribly important to begin with, but well, ultimately it won't be, but 3 is less than 7. So let's take away 3 from both 3 and 7. So if I do 3 minus 3, what happens? Well, taking away 3, it would give me 0, wouldn't it? Okay, so minus 3 here. Now, what if I do the same thing to 7? If I do the same thing to 7, I'm going to end up over here. And what position do I end up? Well, you'd end up here, and this is what? This is 7 minus 3, which is equal to 4. So what are we doing here? We are subtracting subtract 3 from each, from both. So what do I notice? Well, the key thing here is in subtracting, I'm kind of moving my problem. You see here, I'm interested in this length. But that length is exactly the same as that length, right? They're totally identical, those line segments. And the reason this is useful is because, well, the line segment at the bottom is a distance from 0 to something else. And a distance from 0 to something else is an absolute value. So this business about taking away 3 is giving me a way to talk about the distance between 7 and 3 using absolute values, I think. So let's kind of wrap our heads around this quite carefully. Don't want to do that. Let's remove these just so they're not confusing us. So what have we got? So this tells us the following. This tells us that the distance between, well, 3 and 7 is equal to 7 minus 3, which is equal to 4. Very nice. Now, in this picture, we had everything positive, first of all. So 3 and 7 were positive, and 7 was bigger than 3. So we took away 3 just to make it really obvious what was going on, so this kind of fit together. Imagine for a moment, if we weren't too sure which was bigger, 7 or 3, would it still work if I'd mixed up the order? Well, notice the following. Notice that, well, 7 minus 3 is positive, so it's certainly equal to the absolute value of 7 minus 3. Of course, right? But if I take negative of this, it's the same. So if I do the absolute value of 7 minus 3, it's the absolute value of minus 4, which is still 4. So why have I told you this? Well, I've told you this because this means if, for whatever reason, you didn't know that 7 was greater than 3, you could just take the difference between the two and take the absolute value, right? It would always give you the right answer. So we could have calculated distance without knowing. Without knowing. Without knowing that 3 is less than 7. Wasn't necessary, right? I just need to take the difference between the two and take the absolute value. Bingo, that's the distance. So the basic conclusion is the following. This works for any points at all. Absolutely anything. So the conclusion. The distance between any numbers a and b is just equal to the absolute value of b minus a. It's that simple. And maybe b is greater than a, maybe a is greater than b, it doesn't matter. Taking the absolute value sorts everything out. So the absolute value means we can calculate this without having to worry about which is bigger than the other. Just something to say as well, it's symmetric. It's a little bit strange. Why am I choosing b? Why am I choosing b minus a and not a minus b? Well, a minus b is equal to minus b minus a. So that implies that the absolute value of a minus b is equal to the absolute value of b minus a. So it doesn't matter which way around I do it. Okay? So this implies using absolute values, the order doesn't matter. The distance between a and b is equal. So this is a kind of a silly thing to say, but it's totally obvious. The distance between a and b is the same as the distance between a and, or b and a, if you want to write it the way around. Of course, right? It's totally symmetric. It doesn't matter which way around you do it. It's just the length of the line segment between the two. Now you may ask yourself, why would I do this? It's obvious which one's bigger. Like 3 and 7, it's obvious 7 is bigger than 3, just do 7 minus 3, why bother with the absolute value? Well, the problem comes when maybe one of my two numbers is a variable. And for some values, it may be on the left, on some values it may be on the right of the other number. So you can't have a completely uniform description, you need to use absolute values in order to do it. So this is a nice example. For any number at all. For any number, x, the distance, let's say between 5 and x is always equal to, so I'll write it like this, the absolute value of x minus 5. So the absolute value kind of hoovers up the two potentials. It doesn't matter if x is less than 5 or x is greater than 5. You see, if x was greater than 5, the distance would be x minus 5. But if x was less than 5, the distance would be 5 minus x, you see? So we'd need two different formulas. What a pain. But the absolute value saves us. It gives us one uniform description. So this is how you should think about absolute values, right? As distances, giving you distances between things. It's really, really important. So we can use this to do some quite sophisticated things. So we can use this to precisely describe proximity, if you want. So being close to things, proximity in the number line. So let me give you an example of what I mean here. So, example. So let's have quite an interesting example. Let's imagine I want to describe in words, so I can't just hide behind calculations, all points x such that the absolute value of x minus 5 is less than or equal to 3. And just to add a little bit on the end, describe the same points in interval notation. Now, this is really important because this is exactly how absolute values turn up in the early stages of calculus. So let's wrap our heads around what this is saying. So first of all, we've already done this, but the absolute value of x minus 5 in words is the distance between x and 5 or 5 and x, it doesn't matter. Between x and 5. Have I written it down? I'll do 5 and x. I'll do exactly as before. The distance between 5 and x and 5 is the same, but we'll do it. Distance between 5 and x. So in words, what this is saying is the following. I mean, this statement, which looks kind of confusing, is the statement that the distance between 5 and x is less than or equal to 3. So let's draw a picture of that. So that's me describing it in words. It's pretty neat. So let's think what that actually means. So 5 is kind of fixed information here. Let's draw that here. So what have I got? I've got an x, don't I? Right? So where is x going to be? Well, if I draw, so let me draw a thick line like I've been doing before. If I draw a line out from here, the x, imagine the x is at the end of this line, all right? Well, it can't get too far away, because if it gets too far away, the distance is going to get bigger than 3. So basically, I've got two extremes, don't I? I've got this direction, length 3, that's as big as I can get, and this direction, length 3, that's as small as I can get. So let's kind of try to draw both of these. So what do I have? Well, I've got this interval, there. So each of these has length 3. So what are the two positions? Well, up here, we've got 5 plus 3, that's equal to 8. And down here it's 5 minus 3, that's equal to 2. So what does this mean? Well, x has to live somewhere on this interval. Right? If I have my x here, it's all good, right? Because the distance between these 2 points is less than 3. It's fine anywhere, but the moment I get outside, not acceptable, because the distance would be greater than, strictly greater than 3. Same on the other side. So putting this together tells me the following. The absolute value of x minus 5 is less than or equal to 3. This is if and only if x is in the closed interval, because it's a less than or equal. So 5 minus 3, 5 plus 3, and if you want to write that in a less cumbersome way, which is equal to, of course, closed interval 2 to 8. Beautiful. So for a moment, why is this proximity? Well, imagine I wanted to talk about points which were very, very close to 5. I wanted to look at points which were within a tiny distance. Well, then what would I do? All I would do would be replace the 3 here with something much, much smaller. If I replace this with 0.0001, then it's going to be the same deal, but my intervals, it's going to be much closer into 5, right? So I'm going to be really tight in. So this gives me a way of describing positions which are very close to 5, right? If I choose instead of a 3, 0.0001, I'm going to be within distance 0.0001. So this gives me a way of talking about being close to points. It's very, very powerful. So more generally, let's think about what this would look like. So more generally, it's a really lovely idea. So more generally, if I write down the absolute value of x minus a is strictly less than c, this is if and only if x is in the interval a minus c to a plus c. And we often call a the center of the interval. It would be kind of slap bang in the center. Same deal. We've got almost exactly the same, but with closed intervals. So that's open intervals because I'm not inclusive of c, because I'm not equal to c, so copy. So you could have this now, and it would be exactly the same, but with a closed interval. Very, very, very important. Something that will turn up in the early stages of calculus and beyond. It's important to be able to describe being close to points in the number line. It's a very, very critical thing. So very useful. Now I maybe should just say, of course, c here has to be positive, right? You can't have c negative because the absolute value is always positive. So just as a quick example to illustrate something to be a little bit careful of with notation, if I had x, let's say plus 3 is strictly less than 4. Well, this is if and only if, so it's a little bit odd because it's a plus and it seems to be I need a negative here. But remember, a negative is a plus in disguise and vice versa. So this is x minus minus 3, okay? Less than 4. So if I want the exact same notation, a here is not 3, it's minus 3. And c here is equal to 4. So now this is if and only if x is in the interval minus 3 minus 4 minus 3 plus 4, which is equal to the interval minus 7 to 1. Good example. So absolute value, incredibly important concept. It's the distance between a number and 0. You can use it to describe the distance between any 2 points in the number line, and you don't need to worry about which is greater than or less than the other in order to use it. It always works.